Welcome again to the next portion of our course. As far as the next portion of our course is concerned, this portion of course that we are starting from today is what we call as the dynamics. As far as the dynamics is concerned, dynamics is a branch of mechanics in which we study force, we study force, we study the effect of the force, that is motion, we study motion, and we study the variation or the change of motion with time. Okay, and when we say the change of motion with time, we talk about the physical quantities, like we talk about velocity, we talk about velocity, we talk about acceleration, we talk about acceleration. Okay, so these are very important things. So if we study force, effect of the force, that is motion, and variation of the motion in a body in terms of acceleration, in terms of its velocity, we see that we are essentially studying the dynamics of the body. We are studying the dynamics of the body. Now, as far as the dynamics is concerned, dynamics involves the study of force, study of motion, and the variation of the motion with time, that velocity and acceleration. Okay, variation of the motion, we always know that force is responsible for creating the motion, and motion does change with time, and we express the change of motion with time in terms of the velocity and in terms of the acceleration. Not only velocity and acceleration, we have one more term, that's what we call a jerk. Jerk is also the rate of change of motion. Jerk is also the rate of change of motion. As we say, if the displacement of body is expressed in terms of vector s, if x vector describes the displacement of the body, then as we have been doing, ds by dt, ds by dt represents the velocity of the body. This represents the velocity of the body. Rate of change of displacement is velocity. And time rate of change of velocity, dv by dt, we say this is called the acceleration. This is called the acceleration. And time rate of change of acceleration, that is dA by dt, time rate of change of acceleration is what we call as, is called the jerk. Okay, this is called the jerk. Now if this dv by dt can also be written as, this is d2s by dt2, this is the second derivative of displacement. This is d by dt of v, v is equal to ds by dt, therefore acceleration can also be written as d2s by dt2. Acceleration, we already know it is the second derivative of displacement. Okay, in the same way, we can then talk about this acceleration as, this is d by dt of acceleration. Acceleration is d2s by dt2, therefore jerk is the third derivative of the displacement. This is d3s by dt3. Okay, this is the third derivative of the, this is the third derivative of the displacement. So when we talk about the dynamics, in dynamics we study about we study the force, we study motion, we study the change of motion with time in terms of velocity, acceleration, and the jerk. As far as the dynamics is concerned, this dynamics is divided into two branches. It has two branches. Or we can say that we can study the dynamics of the body in two ways. That is, if we study the motion of a body, if we study the motion of the body and the change of motion of the body with time, that is, we study velocity, we study acceleration, we study jerk. And we do not study the reason of the creation of the motion, that is force. Okay, if we study the motion of a body, the change of motion of a body, that is its velocity, and the change of velocity with time, that is acceleration, and we do not study the force which is creating the motion, then we say we are studying, we are dealing with the kinematics of the body. We are talking about the kinematics. So whenever we have kinematics, in kinematics we will only encounter the terms like that of velocity. As far as kinematics is concerned, kinematics is therefore that branch of dynamics in which we study motion. In kinematics, we study motion, and we study the variation of motion with time or change of motion with time. That is, we study velocity, we study acceleration, we study jerk, so on and so forth. Okay, so in kinematics, we essentially do not study the force acting on the body. The force acting on the body is not of any importance as far as the kinematics is concerned. The focus is not on the force which is responsible for the creation of motion in kinematics, but only in kinematics the we study the motion. That is, we study the velocity of the body, we study the acceleration of the body. So this is kinematics. But if we study the force that is creating the motion, okay, then that branch of dynamics is called kinetics. It's called kinetics. So as far as the difference between kinematics and kinetics is concerned, the difference between kinematics and kinetics is the, the study of force. As far as the kinetics is concerned, in kinetics, we study the motion of a body by studying the forces which are responsible for creating the motion. Okay. But in kinematics, we study the motion without without any concern about the forces which are producing the motion. These are actually, kinematics and kinetics. Both are two ways of analyzing the motion of the body. Okay, we can do the analysis of the motion of a body through two ways. One is the kinematic way of analyzing the motion of a body. Another is a kinetic way of analyzing the motion of a rigid body. For example, if we have, say, for example, we have a cart. Okay, let's suppose we have a cart, and this cart, the mass of this cart is m, and this cart is being subjected to force, say for example force m. Therefore this cart will translate along this axis, and we treat this axis, say for example, to be our x-axis. Let's treat this to be our x-axis. Okay, so if we are asked, if a force F is acting on a cart of mass m and the cart is translating along x-axis, what is the position of the cart at time t? That is, we have to understand, or we are questioned about the position of this cart at different intervals of time. For example, at t equal to 1 second, what is the position of the cart from the origin? At t equal to 2 seconds, what is the position of the cart? So we are questioned about the position of the cart at different intervals of, or at different instants of time. Or we may be asked, what is the velocity of the cart at different instants of time? What is the acceleration of the cart at different instants of time? What we are given? We are essentially given the force that acts on the cart. From the Newton's laws of motion, we know F is equal to ma. Force acting on a body is equal to the product of mass and acceleration. We know this equation very well. So this equation is, if we know the force acting on the body, we can know the acceleration. Okay, if we somehow can understand how much force is acting on the body, if we do the force analysis on the body and understand the nature and the magnitude and the direction of forces acting on the body, then we can find out the acceleration. Once we are obtaining the acceleration acting on the body, we know acceleration is equal to dv by dt. Therefore we can obtain from this formula, we can obtain, when we know the value of acceleration, we can know the value of the velocity. And we know, as far as the velocity is concerned, velocity is the time rate of change of the displacement, that is dx by dt. So if we know the velocity, we can also know the position of the body at different instants of time. So this is one way of doing. First is understanding the forces acting on the body, and from the forces we obtain the acceleration of the body, velocity of the body, position of the body. If we do this analysis, then simply we can say that this analysis we are doing is called kinetic analysis. This analysis is kinetic analysis because we are studying the motion of the body by analyzing and understanding the forces acting on the body. Okay, this is one way of doing analysis. Second is, you go in the reverse direction. Don't study the forces acting on the body, but just study the position of the body. Okay, study how the position of the body varies with time. Okay, what is the relationship between position of the body and time? Okay, if we are successful in understanding the variation of position with time, then from this we know, if we obtain somehow the relationship between x and t, then we can obtain the value of velocity. Once we know the value of velocity, we can know the value of acceleration. When we know the value of acceleration, we can know what are the forces acting on the body. So this is coming in the reverse direction. if we know, if we just study the motion of the body without understanding the forces acting on the body, then this analysis will be calling as we are in the we are doing the kinematic study. So studying the dynamics of a body involves the studies of force, effect of the force, that's motion, and the variation of motion with time in terms of velocity, acceleration, and jerk. But if we study only the motion and the variation of motion with time, then we are essentially in the kinematic region. We are dealing with kinematics. Or otherwise, if we study the forces acting on the body without any understanding of the motion of the body, then we are actually doing the kinetic analysis of the body. In this course, we have to do both. We have to understand how we do the kinematic analysis of the bodies and how we do the kinetic analysis of the body. These are very, very important. Now, in the previous classes, in your lower classes, you have been talking about force, velocity, acceleration, okay? You talk about the projectile motion, you talk about the rotational motion, simple harmonic motion. You have done a lot of dynamic analysis of the bodies. But the dynamic analysis that was done in your lower classes is different from the dynamic analysis that we are doing here in this course of engineering. The reason is because we are doing our dynamic analysis on rigid bodies. We'll be talking about kinematics of rigid bodies. We'll be talking about kinetics of rigid bodies. While as in your in your lower classes, you were doing kinetic and dynamic analysis on on particles. Okay, you were saying a particle is moving. Okay, a particle has an acceleration. Okay, that is, in fact, say for example, in your lower classes you had the problems like uh, a car, problem of a car. A car is translating with a velocity of v meter per second along x-axis. On this car there is say there is a projectile. Okay, there's a gun which fires the projectiles. Okay, and the projectile and a projectile of mass m has been fired by the gun which is mounted on this car of moving with velocity v, such that this projectile moves with a velocity of with a muzzle speed of v naught meter per second. Okay, ahead of this car there is a truck. Okay, there is a truck, and as far as this truck is concerned, this truck is translating along x-axis with velocity, say for example v prime meter per second. And on this truck there is a bird. Okay, on this truck there is a bird. They have done these types of questions in your lower classes. On this truck is a bird. Now this a bullet which is being fired from the gun with a velocity of v naught meter per second, and this gun is mounted on the car moving forward with velocity v meter per second. This bullet hits the bird. What is the velocity with which this bullet hits the bird? These types of questions you have done in your lower classes, but essentially you were studying the motion of the bullet. Okay, you are studying the motion of the bullet by assuming that the size of the bullet is very, very small. Okay, its entire mass is concentrated at its center of gravity. It was behaving, you were taking it in the form of a particle. Okay, so in these types of examples, you are doing analysis of the bodies when you are assuming the bodies in the form of the particles. Okay, in the same way, the question is like a person, a car is, or a person is moving forward with a velocity of v meter per second. Okay, v meter per second. Rain is falling with velocity v1 meter per second. Okay, what is the velocity of the rain as observed by the observer, as observed by this man? In these types of problems, you are assuming the rain to be in the form of particles. Whatever analysis you have done in your lower classes, the bodies under the bodies that were under investigation, they were essentially treated as particles. And we have the definition of the particles. A particle, every body is being treated as a particle if its dimensions are more than the distance it travels. For example, a car. If you look at a car, the dimensions of a car are, howsoever big the car may be, it has limited dimensions. And we know the dimensions of the car are, say for example, its length is say for example 4 meters. Okay, and its height is, say for example, 1 meter, or say for example 2 meter is the height of this car. Okay, or you may have a truck which seems to be very very massive and whose dimensions are very large as compared to the ordinary cars. But whatever be the vehicle you have, it has some dimensions, but the dimensions are very small as compared to the distance that the truck travels. If you look at the truck, how much distance a truck can travel? A truck can travel a distance of millions of kilometers. Okay, it can travel a distance of the order of millions of kilometers. But as far as the distance that it travels, you can take a truck from this part of the world to US. You can take a truck from here to North Pole. You can take a truck from here to South Pole. So it means a truck can travel a distance which is very, very far, which is very, very large as compared to its own dimensions. When you have a body whose dimensions become negligible in comparison to the distance it travels, that object is treated as particle. And the analysis that we do is called the particle analysis. Okay, that particle analysis we have already done. For example, in your lower classes you had an aircraft is traveling with some velocity. What is its acceleration? Okay, so what you are doing, you are neglecting the dimensions of the aircraft. The dimensions of aircraft were not coming in your analysis. You were not interested. Whatever be the dimensions of the aircraft, you can do the analysis of in terms of, now rate of change of velocity is equal to acceleration, rate of change of its displacement is equal to velocity. You were never questioned about the dimensions of the aircraft. What will the effect of the dimensions of the aircraft on its velocity and acceleration? Because that analysis was particle analysis. We were treating the bodies in the form of the particles. But as far as engineering is concerned, the analysis in terms of particles is not always satisfactory. And sometimes the analysis is to be done by not treating a body as a particle, but by treating a body with the same dimensions as are given to us. Okay, so at that time we have to treat the body as a rigid body. Okay, we don't treat it as a particle, we have to treat it as a rigid body. Okay, what do we mean by rigid body? Rigid body is that body which does not undergo any deformation under the action of the load. Okay, when you apply forces on the body, there is no deformation in the body does not deform. There is no deformation of the body does not deform. There is no deformation. Okay, the body does not deform at all. When there is no deformation of the body, that's why the body is called the rigid body. Okay, we are doing our analysis on the rigid, like you talk about IC engines, internal combustion engines of your car. We will be doing the force analysis of the IC engines, but we treat these IC engines as rigid bodies. That is, it is to be assumed that their dimensions do not change. The force analysis of aircraft, the force analysis of space shuttles, the force analysis of gyroscopes, okay, the force analysis of pulleys, belts, chains, gears, okay, everything we have to treat that the body is a rigid body. Its dimension, sorry, it does not undergo any deformation. Deformation will mean that its dimensions do not change. For example, let's suppose we have a sphere. Let's suppose we have a sphere. Let's suppose we have a solid sphere, and say this solid sphere is subject to forces, and the forces are, this solid is subject to forces in this direction, in this direction, in this direction. Okay, it is subject to different direction of forces. Now if this is rigid, then its dimensions, its radius will not change, its radius will remain constant. That's what we actually assume. We assume that the body is rigid, its dimensions do not change. If this body is not rigid, then what will happen? This force will create indentation, will create a dent in it, and this portion will bend like this. Okay, this portion will be pulled out like this. This portion will again be forced inside. This portion will again be forced inside. So its dimensions will change, it will deform. But we have to treat the bodies as rigid bodies. We say the bodies are rigid bodies in the sense that they do not undergo any sort of deformation under the action of the external load or external force. Number one. Number two is, in kinematics of rigid bodies, in these rigid bodies, we'll be studying the motion of these bodies. Okay, but the dimensions of the body will be taken into consideration. We will not be saying let the body be assumed to be in the form of a particle. No. Now the dimensions of the body will have an important effect on the motion of the body. Okay, now the dimensions of the body are to be taken into account when we are studying the rigid body. Okay, so it means, as far as the heading of our topic is concerned, if we return back to our topic, the heading of our topic is kinematics of rigid bodies. If we are asked what do we mean by kinematics of rigid bodies, the heading is, so we are essentially dealing with kinematics of rigid bodies. Kinematics of rigid bodies. So what do we mean by the kinematics of rigid bodies? We're talking about the kinematics of rigid bodies. What is the kinematics of rigid bodies? So what are we going to study? First of all, we are going to study the motion. We are going to study variation of the motion with time, velocity. We will be studying the acceleration, okay, of what? And we will not be studying force. We will not be studying the force acting on what? Rigid bodies. Rigid bodies, bodies with some given dimensions. The bodies will have some dimensions. They will have dimensions. And the bodies which will not go under, which will not deform. They will not deform. They will not deform under the action of the load. They will not deform under the action of the load. There, no deformation will rise. That is, these bodies do not undergo any sort of deformation while they are subjected to this load. So this is what we have to study in this chapter. So we will start with, our chapter starts with an important heading. We will start with the kinematics of plane motion of rigid body. So we'll start our chapter with the kinematics. So our heading will be, the first heading of our chapter will be kinematics, kinematics of plane motion, kinematics of plane motion of rigid body. Kinematics of plane motion of rigid body. Okay, this is our title. First, we are, the motion that we are dealing, the motion of the rigid body can be of two types. Now we know what is kinematics and we know what is a rigid body. Now one more term is coming to us, that is plane motion. As far as the motion of a rigid body is concerned, we can have two types of motions. We can have two-dimensional motion, or I will write 2D motion. A rigid body can have a two-dimensional motion, 2D motion. A rigid body can have a two-dimensional motion, or it can have one more type of motion. That's what we call as three-dimensional motion. Both we have to study. We have to study 3D and we have to study 2D motion in this chapter. Okay, though 3D motion is given at the end, but I will be incorporating 3D motion in this chapter. So we have to study the kinematics of rigid body in its two-dimensional motion as well as in its three-dimensional motion. So first of all, we'll be beginning with the two-dimensional motion. So what is the two-dimensional motion? In order to study the two-dimensional motion or this plane motion, what we will do always and every time, as I have been discussing it in previous lectures as well, in order to describe the motion of any body, whether it's a particle or it's a body, very important is expressing the body in some coordinate system, what we call as a frame of reference. That is, you should have a coordinate system. Let's suppose we have a coordinate system wherein we treat this to be our x-axis and we treat this to be our y-axis. We treat this to be our y-axis. And let's suppose this is our y-axis. So this is our y-axis. This is our x-axis. Okay. This is our origin. We have been calling this as a two-dimensional coordinate system. Now, from now onwards, we'll be calling this as, this is our frame of reference. We'll be calling this from now onwards as, this is our frame of reference. Frame of reference is a frame. It is a coordinate system from where we will be measuring our distances, from where we will be understanding the motion. This is called the frame of reference. Okay. So for us, this is the frame of reference. So we say this is our frame of reference. This is our frame of reference. Now, this frame of reference, for example, we were asked, or we have solved questions in our previous classes where we say a car is moving with a velocity, with a velocity of, say, for example, 3 meters per second. When someone tells us that a car is moving with a velocity of 3 meters per second, it means that person is at rest with respect to the car, about which he is giving us the information that the car is moving with a velocity of, say, for example, 3 meters per second. I mean to say, if it is said that there is a car and this car is moving, if it's said that there is a car, for example, and this car is moving with a velocity of, say, for example, 3 meters per second, who is giving us this information? Someone is giving us this information that there is a car C, and this car C is moving along x-axis with a velocity of 3 meters per second. Someone is giving us this information. Okay, we say the person who is giving us the information lies itself on the ground. The person lies itself on the ground. The person is on the ground. The person is on the ground, and the information he is giving us about the car is that the car is moving forward with a velocity of 3 meters per second. That person, the person who is telling us, we say the person lies on the ground frame of reference, which is denoted by the symbol eta. Okay, so this symbol is used for referring to the ground frame of reference. That is, there is a person on the ground. This is the ground. Okay, this is the ground, and on this ground there is a person. The person is lying on the ground. The person is lying on the ground. The person is lying on the ground and is at rest on the ground. The person is lying on the ground. We'll write this as, this is the person P, this is the man. We'll write this as M. The man is on the ground. Okay, and that man is observing the car and is saying that the car is moving along x-axis. Okay, so the x-axis is being specified by the person who is on the ground. Okay, so the person on the ground is at rest with respect to the car and is saying that the car is moving along x-axis with a velocity of 3 meters per second. We write this as, this is velocity V. Okay, this is velocity of the car with respect to the person on the ground. That is, with respect to the ground frame of reference. We write it like this. This is velocity of the car with respect to the person on the ground, and its value is 3 I cap meter per second. 3 meters per second along x-axis. Now, let's suppose there is a boy inside the car. The boy is inside the car. When we are asking boy, what is the velocity of the car with which you are moving? The boy will say that with respect to me, the car is at rest. So it means the velocity of the car with respect to the boy's frame of reference. Okay, velocity of the car with respect to the boy's frame of reference is 0. Okay, so when we are studying the motion, it's very important that we define the frame of reference with respect to which we are setting the parameters of the motion, like velocity, displacement, acceleration. You cannot say that the body is moving with a velocity of 3 meters per second without specifying the frame of reference with which you are measuring this velocity, position, or acceleration. No. So always and always, whenever we were asked that the car is moving, man is running, so this information was given us by a person who was at a frame of reference. That frame of reference was at rest with respect to the object about which he was fetching us the information. Okay, so the frame of reference is very important. So from now onwards, you will not neglect the frame of reference. First and foremost, you will draw your frame of reference, and the first frame of reference which you will be drawing, we will be calling that frame of reference as a ground frame of reference, because all the informations will come to us from the ground frame of reference, because it is the ground frame of reference. It will be observer on the ground frame of reference who will be observing, like an aircraft is cruising. Okay, a car is moving. Okay, a person is riding the bicycle. Okay, someone is running, rain is falling. These all informations will be given to us by a person, by an observer, such that the observer lies on the ground. So first and foremost, to define your frame of reference and call the frame of reference as a ground frame of reference. Okay, so this is the introduction. So first foremost, we'll be defining the frame of reference, call this as the ground frame of reference. Now say, for example, we are rubbing the board, okay, and we have a duster in our hand. We have a duster in our hand and we are trying to rub the board, okay. We are trying to rub the board with the help of a duster. What we will be doing, we will observe what is the nature of motion of this duster. What type of motion is happening in the duster, whether that is a 2D motion, 1D motion, or 3D motion. And from this example of the motion of a duster on a blackboard, we will understand what we mean by the planar motion. And then onwards, we will go to the quantization, the velocity, acceleration, angular motion, so on and so forth of this plane motion. That will be our coming up lecture number 2. Thank you very much.